Okay, so basically, I have some, I think, pretty decent GPG and in general security keys related setup for a few years now, and it was not that obvious to come up with. So I wanted to share because maybe someone else will find it useful as well. So in general, there are a few things, like a few aspects I wanted to show you. The main topic is around GPG, which is about a setup that is actually pretty safe to carry with your laptop, even a laptop that you use in public places where it can be, well, pretty easily stolen or, well, whatever, right? The next two things are about SSH, how you can limit certain stuff with your SSH keys and use different keys for different purposes. And the last one is a little bit about YubiKey, which I already know that some of the people in the company use. But for today, it will be mainly about GPG, okay? One note, if it's obvious, okay, let me know that it's boring and we can like move on. But if it's not and you're lost, ask immediately, because if you will lose like the track of how it works and is configured in GPG, I think it will be really hard to catch up. So in summary, everything is based on the public-private key per security. So basically, the rule is pretty simple over here. We have two pairs that are related, two keys that are related to each other, and they create a pair. And what one key encrypts, only the other in the pair can decrypt. The idea is that your private key is private, so it's secret. It never should be shared with anyone, and it shouldn't be available to anyone. So basically, you use this key to decrypt your messages, and then anyone can use your public key, which can be shared at will, and use this to encrypt messages for you. Okay. In general, there is now a problem of trust. I mean, sure, we can have those keepers, but how can I trust that certain keeper is actually being used by a person or organization that it claims to be? So if we have two users, Joe, he needs to know that there is a certain public key that Bob really uses, and that only Bob has this private key associated to the public one. And there are like two basic models. First one is third party, trusted third party, which is basically like it works a little bit like official ID cards by governments or driving licenses or anything, or actually the public key infrastructure model based on X509 certificates. So basically, we have a third party that everyone trusts, which is, well, an assumption over here. And if we want to confirm that a certain key that we got from Bob, and Bob claims that it's his, if you want to verify that, we check if this key was really reviewed, accepted, and signed by trusted third party. Since both me and, well, Joe and Bob, we trust in this trusted third party, if I see a correct confirmation from third party that Bob's key is okay, I'm automatically assuming that the key is okay, and I can safely use it for encryption. But there is also another model that is called web of trust or direct trust or something like that. So basically, it works without the trusted third party. The whole idea is that users of the system can meet in any way, but in using a different channel that is secure communication, secured by the keys, and they can exchange information about keys they're going to use directly with each other. To confirm that they have verified their keys one to another, they issue signatures on keys. So for example, we have three users. There's Bob. Bob meets with Bill, and Bill checks what key is Bob using and presenting to him. And he can even leave a signature on Bob's key that this key was really checked and verified by Bill. And again, the same story can go with Joe. Joe can check Bob's key. And after that, first of all, Joe can trust this key because he checked directly with Bob that this key is okay. And he can leave a confirmation on Bob's key that me, Joe, I'm signing up a confirmation for Bob that, yes, this is your key, and I have verified that directly. Okay, is it clear so far? No questions? Okay, so this is like about the whole idea. And GPG is an implementation of that second model, so web of trust, where users like should meet with each other and verify their keys. This is actually an open source implementation of a very known product, at least very known a few years back, which was called PGP, and implementation of the PGP protocol, which was quite effective. There's even a very funny story. Like in the 90s, I think, PGP was using so advanced encryption protocols that they were under the US export restrictions. And it was not allowed to export PGP algorithm to any other country in any electronic form, because this was like electronic encryption secret or, well, technology. So there is a funny story because actually they moved PGP, like, well, the implementation of algorithms to Europe by printing them in the US, then getting on the plane with like loads of paper, and then OCRing them on scanners in Europe into the source code, and then they could compile it and normally use in Europe, because the restriction was strictly about electronic export, and it wasn't electronic anymore. But in general, GPG is very popular in open source communities. Multiple projects use GPG for signing binaries like application packages, but also this is the standard that is used with Git for signing commits, also for email encryption, so multiple uses. Because in practice, key exchange, like verification of keys and exchange of keys, is like a little bit unrealistic to be in real world, so meeting face to face. You can always try to confirm and verify your key with other users by some other means, like any other communication channels. And to make it easier to be able to check who trusts whom and who has what signatures from whom, you can actually exchange keys in electronic ways. And you can either do this manually and, well, deliver the key to your, well, partners in any means, by any means, or you can actually use key servers which are available publicly, which can be used for sharing public keys. For some pretty strange reasons, which are partially based on security, partially based on the historical reasons, not every keeper in GPG is equal. So each key in GPG can have associated attributes which go by CSEA. C is a key that can be used to sign other keys. So it is like a key which I can use to confirm and sign keys of other people. Sign is using for, well, digital signatures. E is for encryption, and A is for authentication, because I can use these keys, for example, to authenticate with SSH. So that's a little bit strange, like comparing, for example, to PKI infrastructure, where you have just one keeper. With GPG, you usually have multiple keys. Okay. So why to like talk about it at all? Because with the default settings, what GPG creates for you is a setup that has two keys. One is CS, so certify and sign, and the other one is encryption. And the problem is that if you use this on your laptop or basically any device that can be accessed by others, especially on conferences or something like that, when, well, especially like in a booth or something, you have your laptop unlocked, you can have your private keys loaded into memory and they can be unencrypted and ready to use by GPG agent. So that's a little bit problematic, because then if someone gets into possession of this key, he can not only decrypt and sign messages meant for you, but he can also like sign others and other keys in your name. So there is an idea of so-called laptop key, which is like safe to store on a device that, well, you assume you can lose access to, or someone not really intended to can get access to your device. So the whole idea is to not have the certify key, the master certify key on your laptop. So you create a setup that is safe to use, but you don't really have the certify key there. And that's the concept of laptop keys. The idea is that your C key should never touch your hard drive. So when you generate your keys, you take a backup of this all on some encrypted external storage, which is first advantage of this approach. You actually have a backup of your keys, because like losing your keys is like normal, unfortunately. But over here, you're like forcing yourself to have a backup of your keys, and you're not carrying your C key with you. Of course, the restriction is that if you're not carrying your C key with you, you're not able to sign other people's keys. But to be fair, you're doing this very rarely, right? Normally, you just want to encrypt and sign stuff, or use the authentication key, but not to sign other people's keys. You do this, well, relatively seldom, right? So how to create this key? Because it's a lot of talking, let's do something. Of course, always security is about a compromise between how paranoid you are, how convenient you want your setup to be, and how safe and secure it can be, right? So because it's pretty easy to for the master certify key to never touch your drive, you can actually do something like that. So we can create a tempfs. Sorry, users of other operating systems, I don't know how to do that there. You need to check it up. And now we can create a completely new PGP setup. I have my private one. Okay, let me first maybe show what I have currently without switching to another context. So over here, you can see I have like two keys. One of them is my private key. The other one is my like company key that confirms my identities. Identity is usually associated with email address that I can use for this key. And for my private key, I have like this key is certified. Sign is not really needed over here. And over here, I got separate sub keys that can be used for signatures, authentication, encryption. And over here, this is the key I created recently. This is the master certified key, and I have only sign and encryption. This is the public part of my keys. If I check for private part, it looks like this. So SSB stands for secure subkey. So it's a private subkey. And sec stands for just private primary key. Over here, you can see this hash. Hash means that the private key is actually not available. It is in so-called detached state. This key is present, but only in public part, not in private part. By the way, if someone is using any form of crypto cards or YubiKey or anything, this sign means actually that private part is available on external crypto card. In this case, this is on my YubiKey. There's a tool that you can use to export your keys, private keys to YubiKey. Okay, so this is how my current setup looks like, but let's start from scratch. I need to probably clean up a little bit because I was checking this just before the call. I will copy my GNU configuration, GNU PG configuration file to the new directory. There's nothing really very important there. There's just some preference about which signature methods to use, which encryption algorithm, and so on. Nothing that will change how everything works here. And now we can create our master key and start to create our key. Of course, we are experts, right? So we use the expert option. No, not like that. sorry, as you can see, there's a lot of options for GPG, and actually key creation is not something you do frequently. Let me cheat a little bit. Okay, it's called full generate key, not create full key. Okay, so right now we are starting to create our first key. We use the expert option to actually be able to select the correct mode, so CSIE, and we start with like RSA and set your own capabilities. So we go with 8. And now the default key that it wants to create for us has these 3 capabilities. So sign, certify, and encrypt. We want for the master key to be certifying only. So we disable sign and we disable encrypt. And now we have only certify left. And that's OK. We can quit already. Of course, we should go for like longer keys probably. Now this is like, well, depends on you. In general, you shouldn't be creating keys that are valid indefinitely, but that's something I still do for the master key. As I'm storing the private key in cold storage, so detached from my machine anyway, there's very little chance of like losing this key or being stolen by someone else, so I'm okay with the key to never expire. This is okay. Now I need to give my name, my email address. Comment is not necessary. Here's my new user ID. It looks okay. Now I need to enter. Oh, okay, crap. You can't see this because I'm sharing my terminal only. But in general, it's asking me, the GPG agent is asking me for the master password to protect private key now. So I will enter something strong like test or 1234, because this key is for demo purposes anyway. Okay, I gave it a password, and now my key is generated. I can already see my public part, and I can check my private part. Okay, so we have one secure key, one public key, one secure key, one user identity, and this key is C only. So now what we can do is GPG expert edit key, and this is ID of my key. So I want to edit this key. Yep, and now we can add keys, add sub keys actually. So I'm doing add key, and I will add first sign key and then encryption key. So we can go with like choose your own capabilities, but actually 4, so RSA for signatures is okay for us. We just need to change probably the key length. For sub keys, I'm setting some expiry dates already, because you can always change your sub key, and that's like the part of the idea as well. If you have your master key that is like valid forever and stored securely outside of your machine, you can always change your sub keys. So you can delete them, change them, create new ones, and so on. And that's cool, because if ever for any reason you will need to revoke, delete your private subkey, you can do this, but your key as such, as whole thing, doesn't change. So for example, all the signatures that you have from other people on your key, they are still left intact. So you can basically do anything you want with your subkeys later, and no one needs to sign your key again, and you don't have to distribute your key to other people again. So that's very cool. So for this key, I'm using some like round number, which is roughly 3 years. Yeah, I want to create it. Now I need to give my private password for the master key, because my key as the object needs to be changed. Okay, just a second to generate the key. Okay, and you can see that already I have one subkey, secure subkey, which is for signatures. Let's do quickly another one, this time for encryption, and we have a ready option for that as well. This is here, Rsa Encrypt only. Just change the key size, valid for the same number of days. Yes, create. Now, again, I need to use my private master key to sign that. Okay, and my setup is already pretty good. I have 3 separate keys. I can already see that each one of them is configured for a valid purpose. I save my key, and now I should take a total backup of this directory and move it to a cold storage. So, for example, I'm using this. I'm not sure if you can see it. This is a original, genuine 32 megabytes SD card. No, I'm not wrong. This is 32 megabytes, not gigabytes. So this is my cold storage for encryption keys. So you copy this to your cold encrypted storage, because this is the moment that you want to back
And
up
your cold and your cold storage is lying next to your desk.
Yes.
That's it. Not in not locked down somewhere. Not twice. Not once.
No, it's encrypted.
Yeah, but once or twice. Do you have one of those cards or 2 of those cards?
One. But I have another encrypted backup uploaded to cloud storage.
Okay.
Okay, so now you should do this backup, and now you can do the magic that takes away the private key. So you do we need to do something like that. So we want to export our key to external files. So this is meant basically for exchanging keys with other users, but normally you export the public key. Here I'm exporting my private keys, where the cool option is that I can export separately my secret keys, and I can export secret subkeys. Okay, not like that, sorry. I will override the file. So the first one exports secret key. Okay, and the second one exports subkeys. And now you can do something like that. GPG delete keys. Delete secret keys. Yeah, and it's asking me if I'm sane, if I really want to delete all my private keys. But yeah, that's what I want to do. So we delete all the keys. Now, if you check the setup, you have public keys, but no private ones. So what we want to do now is just import our subkeys, private subkeys, without the master key. And now I'm done. Okay, you do this once, exactly once. Now I'm done. I can already use my GPG key. I copy this. Now this directory can be moved safely to my default setup. Of course, I don't want to overwrite my private real one. This is like that. Now I can copy this, unmount tempfs. Basically, I'm done. I should remove my cold storage. My private primary certified key is safe on a cold storage, and I have 2 keys for day-to-day work. And that's it. Now you can already encrypt, you can sign, you can everything, but I want to show you one more trick, which is basically about pass tool. I need another terminal because I have different variables there. Okay, so pass is basically Git plus directory layout plus GPG. It's an encryption and secret storage system that works in CLI that just initializes a Git directory. The subdirectories in Git are exactly like that. So this is the actual structure. But each of the entries under those keys and in these directories is encrypted with your private GPG key. This is useful for integration with any tool, basically, that wants to get secrets from you, but you don't want to type them over and over, copy them, or whatever else. For example, to use opsctl, I have this alias now. Opsctl basically requires two environment variables to be set, right? The GPG password for the storage, which I got from our key pass and put over here in my secure storage in pass using my private key, and my private GitHub token, which I also stored in pass. So right now, every time I do opsctl, this is really pretty safe because those variables are only set for this process I'm starting over here. They don't exist outside of that context, right? They are not stored in any plain text form on my drive, and I don't really care because if I do opsctl right now, like opsctl list installations, again, you can see this, but it's asking me for my private password right now because I haven't been using my key for over 15 minutes. So agent is asking me to confirm I can use it. Okay, I type it. But if I use opsctl again in the next 15 minutes by default, I think, it doesn't ask me anything. It just works. It takes all the necessary secrets out of my pass storage, and that's it, right? So you can pretty easily integrate it with any tool you want and store everything securely. Pass is also nice to share your secrets with others, because these are keys that were used by Pass to sign all the credentials stored in Pass database. You can use multiple keys over here. So for example, if I get a key from Oli or whoever else, I need to trust this key. So this key needs to be verified. I need to confirm and I need to sign that key. But after that, I can add that person to this database, and every secret in the database will be signed separately and encrypted separately for each of the users. So basically, everyone can encrypt anything from the storage because his key was enrolled into the database of keys used for encryption. But also, at any point, you can remove any key from this set, and everything will be automatically re-encrypted again. So you can change your passwords, roll your passwords, and then this person won't have access to your pass database again. Okay, so that's it. That's basically GPG setup and pass setup that I use day to day. I hope it wasn't very boring, just maybe a little. And of course, you can adjust all of that to your liking, right? I'm not saying this is the only valid setup and everyone should use exactly that. But I know that when I was learning GPG, that laptop key concept was pretty interesting, but it's not enabled in any way by default in GPG. So actually, yes, you need to hack your way to get to this setup. I found no ready option to do that. Okay. Thanks. Do you have any questions?
Presentation. I have a question.
Yeah, thank you very much.
What is the drawback of putting an expiration date on your master secret key? When the key expires, what happened then?
You need to create a whole new key.
And then people would need to sign it again, and you would need to distribute it.
Yeah, that's why basically.
Okay.
I never did that, right? I create the master key valid indefinitely, and then I know that I can do anything I want with that key, and my signatures that I have will be still valid.
Okay, fair enough.
So thank you for this call.
Thank you, Lucas.
If anything, you can always ping me later. And well, I like PASS a lot because it's so easy to integrate with CLI tools. But also, you can always copy from PASS to your clipboard. So there's an option -C to PASS, and then it is copied to your clipboard. So without revealing the password, you can paste it in your browser or something.